knowledge graphs to be taken seriously. Okay, did I spend enough time to get to, so that Boris can speak? 20 more seconds. Okay. You know what? Yeah, why don't we go ahead and just give you the mic? So, Boris Iordanov from Semantic Arts. Thank you.
Thank you. Okay, so it's quick. So I'm so Semantic Arts, just a brief intro what the company is. We are a consultancy that specializes in knowledge graphs, and our kind of superpower is ontologies and modeling, and then everything that needs to happen to make them work. So a lot of the kind of the perspective that I have here is based on the semantic web stack and ontologies. And also I want to say that much of what I'm going to say also is coming from the collective wisdom of my colleagues. Okay, so let's begin. How do I go down here? Oh, I have to click. Okay. All right. So, what's so hard about knowledge graphs is the question, and I would say that graphs is really the easy part of that, because I mean, it's like computer science 101. We know how to deal with the graph structure. The hard part is really when it comes to knowledge, and the reason this is hard is that is the same kind of reason that building software is hard, which is that when you're building software, you essentially need to capture a piece of reality for a particular business purpose and put it on a computer. And this is kind of this is where it gets scary, right? It's not the algorithms that we learn in school. It's when you need to model and to represent. And so to give a little bit of a flavor of what I mean by that, let's imagine we want to build a customer relationship management knowledge graph. This is kind of a very typical and industry agnostic problem. And so what do? You start talking about your concepts and relationships, and you think about having a customer which buys products and issues purchase orders, and they submit feedback and this and that, and little by little it kind of blows out. I mean, you start to wonder, well, should I include invoicing here? Maybe yes, if my purpose is an accounting system. Should I talk more about post-sales activities like service requests and complaints? Maybe, if that's what I want. Should I, what exactly is a customer? Should I distinguish between the person who is buying the product versus the person who is using the product? Because if you're talking about feedback, well, maybe you want to know the feedback from the actual user than the purchaser. And so all these subtleties start to pile up, and you realize you need a process. You need a way to find out what's important and what means what, etc. And hence the need of a process and the need to try to do it in an agile fashion, as we do these days, because that works much better. So when speaking about agile, one thing that I want to avoid here is embracing a specific methodology or trying to promote one over the other. I think that there is this whole philosophy of when you do agile, is it about doing agile or is it about being agile? And some hardcore industry leaders will talk about becoming agile. Is really what it's about, because you have to constantly improve. So I think there are many different ways to do it. I also think one has to be careful not to assume that if you have daily stand-ups and retrospectives, you're doing agile. And so what I want to focus is on the fundamental principles. I think there is an undercurrent, there is a common thread of all methodologies that make agile work. And it's something very simple. It's just this notion of a feedback loop. This idea that we do something and then we validate it, and then we do it again and we iterate and we keep on and on. And so this is why we need short delivery cycles. This is why we need to have stakeholders involved in that validation part to make this feedback loop work, right? And we want to avoid the sequence of starting somewhere and then ending somewhere else. Is the iteration that matters, right? And so in the case of knowledge graphs, what are the, how is that different from software? What are the questions that we want to answer that we already sort of have the answer for in software development, but not so much in knowledge graphs? And so this is where I'm heading. I want to kind of bring the ingredients and the important pieces that would help you create those feedback loops in whatever agile methodology your enterprise might happen to have at the moment. And so some of the questions are, how do we divide and conquer? What does it mean to have something that works? Right? You have a knowledge graph, it contains a model and data, etc. And how do you have something that works in a small cycle? How do we validate that something? I'm having trouble with the. Okay, what's a good sprint story? Is that notion of the simplest thing that works apply here? That comes from extreme programming, where you basically say, I'm not going to spend too much time thinking. I'm just going to figure out what works now and do it, and then go from there. Is that a good idea? How do we do that? And obviously, what does an agile team look like with when building knowledge graphs? And so to go into that, I'm going to take a sort of a backward chaining type of approach, where we'll start looking at validation and what does it mean to validate? What is it that we want to be validating in our iterations? And I would say, as I mentioned in the beginning, it's the knowledge part that is really the hard part that we're putting the work into. So that means essentially the ontology, the model. And so there are two aspects to validating a model. The first one is that you want to be building the right model, hence involving stakeholders and business owners, etc. And the second part is that you want to be building the model right, which means making sure that it's correct and finding some way to validate it's actually correct, which means that you want to be able to get data in your knowledge graph as soon as possible in some sort of way. And so the specifics of that is where we start kind of thinking, okay, how do I test software? How do I test knowledge graph? What's really the difference? Where is that boundary of validating software versus knowledge graphs? And so here is a picture that kind of gives a little bit the perspective of the difference. Software is essentially when you test software, you essentially ask it to do something, and it's about behavior. You have some interaction with it through an API or GUI, and then you get some behavior back. In the case of knowledge graphs, it's kind of simpler. It's essentially a query interface, and it doesn't really matter what type of knowledge graph you're building. Like you can be building a data fabric type of thing where you have to integrate multiple data silos, or you can be building an app backed by a knowledge graph or a chatbot or whatever it is. All those differences stem from the software that sits on top of it, but the knowledge graph is really, and the interface testing is really the querying part. And now querying is kind of technical, and you want to specify your interface in a more abstract and more business-like fashion. And the way we do that is through something called competency questions, which are essentially the requirements, the equivalent of requirements for knowledge graphs. And those are really kind of the bedrock of the interaction between engineers building the graph and the business, and they should be really the thing that is driving forward. And so, what's a competency question now? It's essentially a question that you formulate in English, where you ask something the knowledge graph, and then it gives you back a response. They are WH style questions: what, where, who, etc. And the thing about them is that you have to strike two kinds of balances when you devise them. One type of balance is simplicity versus complexity. You want your competency questions to be complex enough so that it captures a good chunk of the domain that you're interested in, and you also don't want it to be too complex so that you can actually answer it. And then the other one is how formal you get, and this is where it kind of gets a little bit tricky, because you want your question to be stated in English so that business people can understand and can communicate, but you don't want it to be too vague, right? So I would say it should be as formal as possible, kind of as close to a query, but not closer. And so here is an example of something that I would say is not a very productive competency question. Like in that context of a CRM system, let's say you ask, how do I optimize service handling? Right? This is something that I wouldn't expect a knowledge graph to be able to answer that. Right? It's a very open-ended general thing. But then you can start talking to your business analyst and say, well, what do you need to know in order to achieve that goal? And then reformulate something that's a little bit more practical, a little bit more useful. And it might, one idea is that, reformulate like this. What are the common characteristics of the products for which complaints take the longest to resolve? Right? And you look at that and you say, okay, I can see how I can build a graph that, would contain that information. I would need to link products with complaints. I will need to have these sort of attributes around them so that I can know what the products are, etc. And it's an iterative process. This back and forth to formulate the competency questions. So with that, we can picture a kind of a first pass at the knowledge engineering process. We have competency questions. Using them, we sort of create an ontology, and then we go ahead and populate it with data, and then we validate. Right? So it's very straightforward. But again, let's talk a little bit more about the validation part, which is the hard part. And I kind of put a box here. It's a separate step, but it's really something that goes on, throughout the whole cycle. You do validation by reviewing your model with subject matter experts. You can do this very early, and you can do this very often, and it's very useful to socialize that and to keep doing it. If you are an OWL geek and if you're kind of math inclined, and you can actually go and specify precise semantics for your classes and relationships, and use the reasoners to do consistency checks, that's a good idea as well. It does detect problems sometimes, like you think something is disjoint and then it gives you problems and things like this. And clearly having a schema that helps you validate the data is good, and running Sparkle queries is another way to test, basically. Now let's go a little bit more into data and what do we do when we're loading data, because there's some important aspects there that bear analyzing more. So the first thing that you do when you're dealing with data is figure out what data you have available and how good it is, and whether you can link it. And so it seems like trivial, but so often we work with clients who are focused on the model, and this is the fun part. Like you go into modeling, you go into trying to understand the business and the domain, etc., and then you end up not being able to do much with it because you don't have the data, you can't connect it. Like an example here could be again in our CRM case is. And that actually happens, with companies, because applications get built at various times, in the history of the company for whatever purpose or intent. So you might have a system managing complaints and somebody logging complaints about products, and another one having being a customer database, and the system managing the complaints never bothered to record the people and who are complaining. So you can never connect customers with complaints, right? And that happens. And so if you go with a bunch of competency questions and models to assuming that you can actually connect those two things, you might have a major project setback if you find out that that's not the case. And then obviously the data mapping part, I think most people are familiar with, where you map data sources to the model and the ingestion. So the point here is that this analyze part of the data is something that you probably want to insert in the process early on, and you probably want to do is even before starting to model, because it's sort of a feasibility step that you take, and you make some decisions. Is that doable? Is that hard or easy? Or how can I go around problems that that I see? So we have these 5 steps here, which look much closer to what actually could work, and now the challenge is how to create a story to fit in a sprint around that, right? How do we make this work? And so at Semantic Arts, we have this slogan that I think a lot are familiar with, which is think big, start small. It's essentially a divide and conquer mindset, where when building the ontology, you want to keep a realist mindset where you focus on the domain, you focus on the big picture, you think long term. You don't want to base your effort entirely on the on the some data set or a particular app in mind. But at the same time, you have to start smiling. You have to be building something that's useful at the moment. And so one way to break down, take a small bite, is to pick a highly abstract fragment of your ontology, something that is that doesn't even care about data at this point. It's just kind of a surface layer. For example, products, complaints, and customers, just those three entities. Can we take them? Can we load them? Can we link them? And that gives you kind of an initial cut. Another way is to just focus on part of a competency question, just on one, something that involves one or two entities in relationships. Take a bite like this, or even look at the data, which is not the ideal thing, but you can do that. But going at staying superficial is one of the things that I personally would recommend. Very forcefully, because too often kind of going down into a rabbit hole of modeling something in detail would distract and would kind of derail from important things. It is very tempting when you get thrown some information or some data set or some subject matter expert get passionate about a certain aspect of their domain, and you kind of go ahead and elaborate on all of that. Don't do it. Stay superficial. It's a good way to maintain the small scope and get something working, and it's a good way to figure out what the important entities are that you want to glue together, and whether you can actually glue them together, which is what knowledge graphs are about. And so this is such an important thing that we have a name for it. We call it a parti, and so this comes from the French expression prendre parti, which means to take a side, or to take a stand. And this is something that architects do. It comes from architecture, where they, before creating a detailed drawing of something, they would create a very rough sketch, deliberately avoiding drawing straight lines, even though they're very good at that. They just deliberately avoid doing it. They just do it by hand, just so that you don't think about the dimensions, etc. You just want to have an idea of what the rooms are, how many rooms, how many floors, relative proportions, things like this. And for us, this is like the analogous to this is concepts and relationships at a very high level. You can already answer questions about the utility of your approach and whether it's doable. So this is a key concept, and it's we think it's so important that we would do it as a separate step. And now I've drawn this picture, which is just a way to help map the kind of the steps of, I would say, don't take this as a process, like as a firm process, but as some steps that you can sort of combine and order in a logical way. And again, depending on how you do things already, but they're kind of logically separated into two modes of thinking. One is the kind of the analysis mode, where you, on the left hand side, where you have competency questions, then you do these high level, highly abstract models that are very, very rough and don't care that much about data at this point. And then you try to figure out what data you have, and maybe you actually handcraft some examples. You don't try to load data, but you just write some example and see if the model makes sense, see if what it takes to answer competency questions. So that's one model. And the other one is when you're actually building, when it's a bit of a more of a deep dive, when you iterate on writing the details of the model, writing the details of the ETL process that you're going to have, and actual queries, etc. And you combine those two. You can combine those two in as kind of a separate phases, or as iterate within one or within the other in sprints. And a few words about team composition. This is nothing maybe that much surprising here for most people. In In a knowledge graph team, you need an ontologist, somebody who understands how to model correctly and who can who has maybe more of a contemplative mind and kind of thinks about definitions and relationships and things like this. And then you need somebody who can attest to the business value of the whole enterprise, the whole project, and the competency questions, etc. And you need a domain expert. So now there is a question whether a domain expert should be part of the team or not. Typically, they have many other things to do. They can't really, join daily stand-ups or whatnot. But at least you want to have some regular sort of interaction with them. It's super important. And so I would say that there should be somebody embedded in the team, at least in a kind of loosely connected fashion. It is critical. And clearly, you need a data engineer or a developer to do the data munging part. So another note on and I've kind of touched upon some of those. What does it mean to go a bit too far here, and some of those ideas and what would be pitfalls in this approach. So one thing is that I talk about how it's important to work with data as soon as possible and often, because it's the best way to really test it and validate it. And so avoid being drawn in it too much. I mean, there is a lot of accidental designs in schemas, that the legacy systems that you wonder. Yes, I'm almost done. I have the watching the clock here, and I'm doing better than I thought. So that's good. So yeah, avoid drowning in data. I mean, try to stay abstract and try to and it's hard because very often schemas that exist, they have been designed with some abstractions in mind and with some forethought and by smart people, etc. So they will inform you about the domain to a fair degree. So they are useful. It's useful to go and look at how somebody modeled in a relational database or in somewhere else. But be careful. Then the other thing that's a little bit less obvious, I think, is I think when we're building, when we're creating ontologies, we do want them to be grounded in reality. We do want to have this perspective where we stay independent from whatever the current application that we're building is, or the data set that we're trying to capture. So and this is hard because it has to be driven by business. It has to be driven by for providing business value. But at the same time, you want to have the long-term being perspective, and so you want to strike this balance where you don't want to let the apps and the data run the show, right? And finally, to wrap up, let's look at the 4 core values of Agile that that were spelled out in the Agile Manifesto, and see how we do with them in knowledge graphs, and based on what I just said. So the first one was individuals and interactions over processes and tools. And so I think that kind of comes naturally, because building a knowledge graph is a lot about extracting knowledge from folks in the enterprise. So you have to be socializing business concepts. You have to be eliciting knowledge and capturing some understanding. And sometimes actually what happens is that you find out that different players in an enterprise, different departments would find, because of the ontology effort and because they're forced to define precisely something or come to an agreement to something, they realize that they had different understandings of things that they've been working with for years, and they kind of we didn't realize we had this. So it helps the knowledge management in general for the company. The other one was working software over comprehensive documentation. Now I think we what we do here, I think I showed. I mean, basically the whole idea is to take a competency question and a piece of the model, either abstract or very specific, and then you try to make it work and try to see how you would write a query for that in just that part. It kind of boils down to that. And customer collaboration over contract negotiation. So this is not much different. I mean, the whole point here is that by having short delivery cycles, whoever the sponsor is or the stakeholder is going to be forced to engage. And then the final one is the one that I am kind of a little bit more ambivalent about, which is responding to change over following a plan. And so here, I have a problem with dealing with change in knowledge graphs. I know that we can change ontologies easily. They're, unlike code, they tend to be shorter. So if you want to go and reshuffle things, it takes less time to manually go and restructure. That's easy, but the problem is that our tool chain is very diverse. We have a bunch of different languages, and we don't have a unifying tool or unifying common language that would unify OWL, Shackle, Sparkle, all the ETL tools, etc. So if you change the model, the kind of the trickle down effects of how that affects your query or how that affects your data loading process, you're really on your own there. And I think the industry has some catch up to do to remedy that. And good timing. Yeah.
Okay, thank you. Now, we only have about a minute left for questions. Pete got his hand up first. I have a bunch of questions too, but I'll let Pete go first. And I seem to only have one microphone, so I'm going to have to do a lot of running around.
Hi, thanks. So your method seemed to be focused on effectively creating almost a data warehouse or knowledge base warehouse based on loading external data, applying ETL to it, and then reading it and querying it. Have you given any thought to an agile method of actually developing knowledge graph-based applications where you're actually developing code and use cases and user stories on the knowledge graph itself rather than just queries on the knowledge graph?
Yeah, so I think relatively the same thing applies here. I mean, loading data is one of the bigger issues when you do have to deal with data. So I've elaborated a lot on that. But the idea of writing competency questions and trying to separate that as a boundary between the software and the APIs, it remains the same. I mean, you have to have some way to populate that knowledge graph, right? If it's handcrafted knowledge, then you have knowledge elicitation issue, which is a whole problem on its own, which I haven't addressed and which is difficult. But in terms of APIs and apps building on top of a knowledge graph, I mean the boundary is the same. I mean you want to have that as a separate component, so you have to have some way to specify the interface to the knowledge graph, and I think that's the way. I mean
We've got update as well as querying considerations to apply.
We're afraid we're out of time. Yeah, I've got lots of similar questions along those lines as well. So thank you very much. A very obviously a thought-provoking talk, and I have a feeling you're going to get buttonholed by a lot of people during the coffee break. So let's give Boris a hand.